Welcome to today's tutorial on implementing secure data aggregation in Java. In an era where data privacy is paramount, it's crucial to understand how we can securely aggregate sensitive data. Today, we'll be covering the principles of secure data aggregation, encryption techniques, and implementing these concepts through hands-on coding examples in Java. Let's begin by defining what data aggregation is. In simple terms, data aggregation is the process of collecting and summarizing data from multiple sources. However, when dealing with sensitive information, such as personal identification data or financial records, it becomes crucial to handle this data securely. Next, we'll delve into the security aspects. To securely aggregate data, we should always consider encryption, secure communication channels, and access controls. This ensures that even if data is intercepted or accessed without permission, it remains unreadable. In this tutorial, we're going to utilize the AES encryption algorithm to encrypt our data. AES, or Advanced Encryption Standard, is widely used across various secure data applications and provides strong security. First, let's set up our Java environment. Make sure you have the latest version of Java installed and an IDE like IntelliJ IDEA or Eclipse for coding. Let's quickly check the required libraries for encryption. We'll need javax.crypto and java.security packages. Now that the environment is ready, let's create a new Java class called Secure Data Aggregator. This class will hold all our methods for encrypting and decrypting data, as well as aggregating it securely. In our Secure Data Aggregator class, we will first implement a method for generating a secret key for AES encryption. This key size can typically be 128, 192, or 256 bits. For this tutorial, we'll go with 256 bits as it provides the best security. Next, let's add an encryption function. This method will take plain text data and the secret key as inputs and will return the encrypted data as bytes. Now, let's implement a decryption method. This method will take encrypted data and the same secret key as input and will return the original plain text. We now have our encryption and decryption methods ready. Let's build a simple example to aggregate data securely. Imagine we have a list of user data that we want to aggregate securely. We will encrypt each piece of data before storing it. In the aggregate data method, we generate a secret key and encrypt each data item before storing it in a list. This ensures that all user data is kept secure throughout the aggregation process. However, remember, managing the secret key is crucial. Next, let's create a simple user interface to simulate user data input. We will create a list of user data strings for demonstration purposes. You can imagine this list being input from a form or a database in a real application. Before we run our code, let's add error handling to our methods. Proper error handling is essential in real-world applications to prevent crashing and to provide useful feedback in case of failures. Now, let's test our secure data aggregator to ensure it works correctly. After running the program, check the logs to see if any exceptions occurred or if the aggregation was successful. This will help us confirm our data is being handled securely. Alright, now let's take it a step further and discuss how we can store the encrypted data safely. In practice, you can store this data encrypted in a database or on disk. However, it's critical to protect the secret key as well. To ensure that the secret key is safe, consider employing key management practices like using a hardware security module, HSM, AWS KMS, or similar solutions that provide controlled access to secret keys. Let's wrap up by summarizing what we've accomplished today. We have understood the basics of secure data aggregation, implemented AES encryption and decryption in Java, and created a simple aggregation mechanism that keeps our data secure. As you develop secure applications, always remember that security is an ongoing process. Regularly update your libraries, use secure protocols, and stay informed about potential vulnerabilities. Thank you for joining this tutorial on implementing secure data aggregation in Java. If you found this video helpful, please like and subscribe for more programming tutorials. Have questions? Drop them in the comments below.